Now the last chapter is gases. What's unique about gases? Somebody will tell me. So, well, if you look at the liquids and solids, they by themselves, they have distinct shape, correct? The liquids sort of, their shape is their container, but gases has no shape whatsoever. The particles in gases are spread all over the places, correct? So their volume is huge. So you'll see their volume is all over, they are all over the place. So what's the volume of air inside this room? Well, the volume of air in this inside room is the volume of the room itself, because we don't know. If the gas is filling the air is made of nitrogen, about 75, 70 something, and about 20 something is oxygen, and some CO2 and some inert gases. So all this air here, the volume of it is the volume of the room itself. So that's unique about this. That's not the solid, that's not the liquid. The liquid, they have distinct, although they take the shape of the container, correct? But they are still distinct though. Another thing is very unique about the gases. The gases can be compressed. You have a gas, you can make after the gas solid or liquid, correct? So if you have a gas like carbon dioxide solid, you can make out of it carbon dioxide powder, like the fire extinguisher powder, the white powder coming from the fire tank, the red fire tank, the extinguisher. So it's carbon dioxide, it's a gas. So you will see it, somebody will flush you with all this CO2, white powder, and this CO2 is a gas that's compressed under 2 atmospheric pressure or 3 atmospheric pressure, and you keep it for a couple of minutes, the whole thing will evaporate. You don't have to even take it or rub it out of your face. It just go by itself. So gases are compressible, so they can transform from one state to another state. So if you press oxygen too much, you can make of the oxygen a very nice blue color, blue liquid. Oxygen is a blue color. If you press it too much, you can make out of it crystals. So you can see those gases can be compressed. Then, unique about the liquids are moderate in compressibility. The solids, they are not by all means compressible. They will break. If you compress any solid, it will break. So they are not compressible. What else? Well, electricity. Electricity depends on the polarity, correct? However, most of the gases are non-polar. Most of the gases are non-polar nature. They are not conducting electricity. Solids in general, they are ionic mostly, and they are polar, most of the solids. The liquids, it depends. They are moderate, so they can be liquid or they can be polar or non-polar. But gases in nature, they don't like to be polar. Imagine you have a polar air, what will happen? If there is a lightning, everybody will be electrocuted in their houses, correct? Everybody will be electrocuted, and that's not happening, correct? So what else? Well, gases in general, they have no color. Can you see oxygen here somewhere? No. Can you see carbon dioxide? No. You can't see. But liquids, most of the liquids, they have color. And solids, a lot of solids, they have color. So some of the solids are very colorful, very nice. They have very nice color. But gases in general, very few they have colors. Like nitrogen dioxide, brown gas. Correct? But most of the gases are what? They have no color whatsoever. And that makes them very dangerous if you have carbon monoxide or carbon dioxide poisoning at home. If you kept your furnace on and all the wood is transferring into ashes, but you have all the soot coming, all carbon dioxide coming to your bed, you'll be next time dead. And nobody will even watch that's carbon dioxide or carbon monoxide poisoning, unless somebody will, make testing, forensic testing to see what the cause of the death, and it is poisoning. So carbon monoxide or carbon dioxide poisoning, suffocating from oxygen, correct? So in general, they have no color, and their density depends. Some of them are heavier than air. Some of them, the reference is our air. Some of them, they are lighter than air. The lighter than air, they go up. The heavier than air, they go down. Like today, we did carbon dioxide experiment. Carbon dioxide heavier than air is always sitting what? Sitting inside, very low. And those creepy movie in Halloween, you see them, those movie in the graveyard. The graveyard, see a lot of smoke. That smoke is carbon dioxide, like a fire extinguisher. That's carbon dioxide. Carbon dioxide, very creepy. If you compress it enough, you make out of it like a fluid, not a solid, not a liquid, not a gas even, not a gas, but it's very creepy, and because it's heavier than air. So it goes down very, very, very low. So those are the characteristics of a gas. And the gas can behave, all the gases are behave really. So, but we have some conditions that the gas can behave ideally. So well, that's at the sun conditions. So if you have very extreme high temperature and very low pressure, then you say, okay, this gas is behaving what? Ideally. But in the real life, there is no ideal gas. All the gases, they behave really, with the real interaction with their vicinity. So there is no ideal gas, but we use them to make the calculation easy, right? I will, because we have plenty of time, I'll stop here. I'll give you 5 minutes bonus, and then we'll come back, and then we'll talk about the characteristic of gases. We went through this together here. So we talked about this, right? And then we'll talk even further about characteristics of gases. Okay, there is a quiz still on till today, so please plan to take it on time. Okay, good luck, and you have 5 minutes. I hope if they are out, you can go and write your name. If they're still out, I'm not sure. Guys, thank you very much.